Hey everybody, it's another episode of All Things 3D. It is Wednesday, December 3rd, 2014. Welcome December. And today we have a special guest, Dr. Robert Crockett. Cool name. I'm your co-host, Chris.
Hi, and I'm Mike, and this is Dr. Robert Crockett. How are you today?
I'm doing well, thanks.
So, since we've already identified you, maybe you could repeat it one more time, because I normally take this little section out in our podcast and start immediately with the guest. So why don't you go ahead and tell us your name, and where do you reside, and what is your profession?
So I'm Dr. Bob Crockett. I'm a faculty member at Cal Poly San Luis Obispo. I live here in San Luis Obispo, and I've been around at Cal Poly for the last 14 years.
Great. That was short and succinct, and I wasn't
I'm a Cal Poly grad.
All right.
Yeah.
This is a Cal Poly grad.
A lot of those Cal Poly grads get a lot of exposure to not just 3D printing, but 3D modeling, and they have a pretty decent SolidWorks curriculum over there.
Absolutely.
I know I work with a lot of people that came out of that, got churned out of the Cal Poly, so
it's very hands-on and rapid prototyping, 3D printing, and CAD is all part of that. Yeah.
That's awesome. So anybody out there that's looking for a school, Cal Poly's a good one.
Yeah, and it's a great location as well. So, in fact, what's interesting, as you probably can attest to, and may I call you Bob? Is that all right?
Yes, absolutely.
Okay. As you can attest to, a lot of people decide to try and start a business or do something while still here. You know, it's funny. I've been here for, gosh, more than 20 years now. I actually came more from the East Coast, or actually from the deep down south. I was a technical instructor out at Keesler, and then I moved in to do some other stuff. Stayed in Houston, and then finally moved out here on the West Coast. And one of the things that was mentioned to me many times is, you know, you don't need a lot of money here. It's just a beautiful location, so who needs a raise?
That's right. That can only go so far, but yes, that's...
I totally agree with you, and I think many businesses have realized that that's not going to cut it anymore. But let's kind of talk about your background a little bit, Bob. You've kind of been around, and we're going to talk about something really cool a little bit later. But you started out, what, in mechanical engineering, and then you have an MBA, and then material engineering, and now you're in bioengineering.
And most of my work was in aerospace engineering. Yeah, so I've kind of bounced around a lot.
And yeah, actually, I think there was only a little tiny section out there in your CV for Cal Poly. So it appears you probably get bored very quickly.
Yeah, I think that's safe. I think that the common thread through all the stuff that I've done is that I like making things, and I like making things that are tough. Meaning that biomedical engineering, for example, is a perfect fit, not because of the medical aspect of it, but because the human body is just such a tough thing to build upon. It's squishy. It's very specific geometry. It's organic shapes. It's everything that we can't do as engineers. And so that sort of challenge has been consistent throughout aerospace and some of the company work that I've done in biotechnology and biomed, and that's why 3D printing has been a part of my research. Even though it's a diverse background, I've been involved with it through all these different industries, because it's the way that we can make these sort of very strange shapes, material combinations, and other things.
Yeah, and I work a lot with organic 3D printing as well as modeling, but not the squishy type. Well, I guess if I use the rubbery type materials, that would be the case. But,
and Bob, what kind of 3D printing are you doing? What kind of 3D printing are you doing now?
Right now, honestly, I haven't been involved in materials research in 3D printing for probably about 7 years now. So I'm, what we're talking about today is ancient history. My involvement with 3D printing today is more on the entrepreneurial side. So I have a company that is kind of an incubator for startup companies in the biomed field, and most of the product development work that we do, and most of the work that I do with students here, uses 3D printing for early prototypes. So I am a stereotypical user at this point, and I love it.
So mostly FDM nowadays.
Yeah.
Yeah. Let's go back a little bit, Bob. How has, let's say, just 3D printing or 3D fabrication, you mentioned to me in our lunch opportunity, I don't know, what was it, 2 or 3 months ago, that you had this interesting case, and I don't want to really give it away right now, but that you used a certain style of 3D fabrication, but then you just alluded today that you've used it and did some studies well before the International Space Station 3D printer
Right.
for zero gravity. So
Right.
can you kind of go maybe a little history arc of what kind of 3D printing you've used in your research?
Yeah, so most of my work, and this is dating back to what 2000 and no 1993 is when I became involved with rapid prototyping, or solid freeform fabrication as we used to call it back then. And most all of the work that I did with that was in deposition techniques. So the commercial system is the Stratasys system, or the fused deposition modeling. But I wasn't really doing that. I was essentially abstracting that. So if you've got an XY plotter and a syringe with some sort of goo in it, and you lay it down one layer at a time, that's what we were working on. And the first work that we were doing was actually how to use rapid prototyping as a manufacturing system for, not for the space station, but for a lunar base. That back in 1992, 1993, everybody was saying with a straight face we'd have a fully manned lunar base by 2005, and of course we don't. But back then there was lots of activity in how do you use lunar resources to build useful things, and how do you not have to bring a full machine shop up to the lunar base, and how can you live off the land? And so we were doing some early experiments with taking lunar soil and essentially extracting a glue from the lunar soil. It's a silicate polymer, and then mixing it together in what ended up looking like a milkshake, and depositing it layer by layer from a syringe, and creating ceramic objects which would be useful for different structural applications and things like that. So back in 1993, I was doing deposition of ceramic slurries to make functional parts, and that was what started it off. The funding for that ran out because we realized that we really weren't going to have a lunar base. This is when the aerospace industry was kind of contracting. But I kept the same basic idea and continued on with how do you take a liquid solution and deposit it onto a solid surface and have it harden. So that was the earliest work we were doing. And back in those days, we had to roll our own. I was using a syringe-based system that was an adhesive depositing system, and using macros in AutoCAD, essentially using the cross-section hatching from an AutoCAD back in 1992, the version I had,
How
and writing
funny.
macros to slice my own systems. And there weren't that many other people that you could call up and share tips and tricks. So everybody was kind of doing their own thing back then. But it was a lot of fun.
Now
Interesting.
you say you were doing scripts. What was the scripting language in Auto? Because I
It
think
was
it's something
just
you use today.
a macro language where you could automate the standard menu tasks. And so I would take a cross section of a 3D object, do a standard cross hatch, and turn that into G code, and then do it again. And this whole process, just the computation back then, would take 5 or more minutes per slice. Just for
But did you do your own G code interpretation, or did you have some source code at that point?
No, you do your own. That's when you're a grad student, you got nothing but time.
Well, what's so funny is that we just saw in the news, 2 or 3 weeks ago, Chris, about the ceramic large, what was it, a Delta type printer. I said, wow, this is great. Never seen this before. And then we bring somebody like you on. What has it been, about 20 years, 24 years now?
Yeah.
That that's old hat. And as we
Yeah,
go
well,
through this, you're going to keep saying, oh, that's old hat.
Yeah, no, as I mentioned to you in another conversation that we had, back then in those days it was really the Wild West, and you couldn't fall off a log and do something and not help but do something interesting. So we did a lot of fun things that were sort of proof of concept or proof of principle, and we never really went deep into them. And so what you're seeing today with the systems on the space station and systems being used for forensics and systems being used for bioprinting and all those sort of things. We did some work in that 20 years ago, but it's taken that long for the technology to mature to make it a truly useful system and not just a gee, isn't this cool?
Right.
But I got to tell you, personally, it was fun to be in the gee, isn't this cool stage. I enjoyed every minute of it.
Speaking of cool, I'm going to go right into this video clip that you sent me.
It's a startling
can everybody hear it there in the
one out of
background?
every 4 murders in America
So
goes
this is
unsolved.
extra, and they've been
Last
around
year
for
it
some
seemed a
time, but this
mysterious
is an
Wisconsin
unsolved
case would be added
murder.
to
In
that
fact, I
list.
did some more
That
research.
isn't
It
till
is
an
no longer
unlikely
an
crime
unsolved murder.
fighter
So
stepped
I'm going to go
in.
ahead and just
Tina
go
Silva
straight
explains.
to the full video, and then we can just keep listening to it. It paused on me.
They had a crime, murder. They had a body, a dismembered female found floating down the
So
Wisconsin
you can talk
River.
over this if you'd
But
like,
for 6 long
Bob,
months,
but
what Sauk County
essentially,
Detective Joseph
let's
Welch
see if we
didn't
can
have was the
recognize
identity of the
Bob in this.
brutalized young girl.
Bob, how old were
The
you?
face was actually removed.
Now, I
To
had more
reveal
hair
the
back then.
victim's
That
face
was
and ID her using
quite a
her
while
real
ago.
skull would destroy valuable evidence. Worried the killer might get away with murder, the FBI, it's called rapid prototyping, or RP, technology normally used
There he
to build
is.
industrial parts.
We've never done anything that's actually been used to help solve a crime.
They have now.
How's it feel to
Last
see
December,
a
Professor
younger
Robert
version of you?
Crockett and his student
Yeah, I like
Dr.
that. I like the
Interstellar.
ponytail. Definitely was that dates me, but
charged with making a model of the victim's skull.
The process
I
itself
know,
is
they're
high
still
tech, but it's
popular
actually
here on-
surprisingly simple.
Here's how it works.
Post a lot
A
of
CAT scan of the
older
real
guys have
skull is
pony-
put into a computer, which creates thousands of skull cross-sections. Then a laser cuts those sections out of paper.
After it does that, more of the paper is laid across the top. It's pressed down onto the previous
Chris, we
layer,
talked about this
and the
too,
laser
you
cuts the
mentioned
new layer.
earlier the
You can imagine
M4.
if you keep on
It's
doing
just
this
so
and build it
funny
up,
how
you'd end up
watching
with a
that
whole
and
object.
watching the
10,000
M4
layers
is
and
just
30 hours later, the astonishing result. A skull scientifically identical to the victim's.
They did an excellent job.
Next, forensic anthropologist Dr. Emily Craig puts a face on the skull, using erasers to judge tissue depth, and clay to fill in the flesh. Suddenly, a face.
This is just going to show how the same face looks totally different.
Using
You know
special
what?
software, Dr.
I just
Craig made
realized
10
I didn't
different
switch
images.
to this camera.
Same face, different hair, even one with glasses. Detectives chose 4, and canvases stayed with this poster. Finally, in January,
Somebody actually recognized one of the pictures on the poster.
this picture, in fact, a mirror image of Muvana Kupaza, a 25-year-old tourist from Tanzania.
It's beyond words on how close I think that it looks to the actual victim.
With the name, the police investigated Muvana's final hours and arrested Peter Kupaza, her first cousin. He's now awaiting trial for murder. It's an arrest that might never have been if not for this innovative process.
You probably
and the
know the
work of
answer
these
to this,
high-tech
Bob,
crime
but I
fighters.
did some
It's a
further
direct
research
result
after
of facial reconstruction. That's just completely exciting.
this to
Amazing.
determine
The FBI
it
was
said
so
that he
impressed
was
with Crockett
arrested.
that he's been
I
asked to
was
help the
wondering, was there
agency
actually a
with future
conviction?
cases.
And there sure was. And there's another article. Let's see if I can bring it up real quick. So let me jump.
And how long ago was this? Did this all take place?
This was 99, I think, 98,
Yeah,
99.
1999. It was July 1999.
Yep.
And
And you were using LOM, and so when
yeah, let me finish the article, Chris, and then so essentially, from what I understood, this man was arrested and then later convicted, and they found blood in his apartment. He supposedly back in Africa had been doing animal slaughters, so that's how he was so well versed with the ability, as you're probably aware of, Bob, not to bring back bad memory, but he literally cut up this person and removed the face. And this
Yep.
is where your work became very important, is reconstructing from the skeleton and obviously the forensic sculptist to be able to come up with almost an identical model. So
Yeah,
it also meant, go ahead,
Go ahead.
Bob.
No, I was just gonna say that if they had found a skull, they would have used that directly for the forensic, the facial reconstruction. But they had a head, and they really didn't want to, even though the face was gone, there was a lot of soft tissue around that provided clues like cut marks and other things. They didn't want to have to remove the rest of the soft tissue to do a facial reconstruction on the skull. And this is the first time that anybody had tried this in an active case. And the Sauk County Sheriff's Department had heard about some work I did, similar work, not with an active murder, but with Indian bones, artifacts that we found in Milwaukee. And so he cold called me and said, "You want to try this?" And we did. We brought the head to the medical center, did CT scans through the bucket so we didn't freak out anybody in the waiting room. I got an optical disc with the data, and using the Mimic software, which was just brand new back then. We essentially just extracted the skull in a virtual environment, built it on LOM, which is that paper process that doesn't exist anymore in that form, but it was perfect for that application because the resulting skull was not only life-size, but because it was made of sheets of paper, it had about the same density, the same look and feel and warmth of a skull. And so it was very familiar to the forensic anthropologist who's used to working with skulls. But then because we also had the full CAD file of this skull, we could take cross-sections and point-to-point measurements for a whole list of different important characteristics of the skull that you wouldn't be able to do if you were just measuring it with calipers. And so the anthropologist had a very rich data set, and as a result was able to do that good a job on the facial reconstruction. And so the punchline is that as soon as they found, this was a cold case because nobody that matched the description of the victim it was reported as missing. And it wasn't until somebody identified the victim on the poster, at that point on they knew it was the killer was arrested just a couple of days afterwards. It was very, very easy to put the pieces together once they knew who the victim was. And he was tried and convicted. And interestingly, this is something that during this whole process, I'd never really been involved in biomedical engineering before. This is kind of what got me into biomedical engineering. And I was interested in the challenges, the technical challenges, but it wasn't until about a year, almost a year after this whole case, I got a letter from the victim's parents from Tanzania thanking me and the team for helping it out, because even though it was a tragic ending, it at least put closure to the whole thing, and that was very powerful in that it shows directly how impactful some of these technologies are to real people.
And, that's a very important point. And again, these links will be in the show note. As you said, the father was from Tanzania, and the guy had said, "Oh, I've been talking with him for several years now," and the reality is he hadn't been. But the more important thing, she was an immigrant. I don't even know if she was an American citizen at this point.
No, she was a visiting student.
So we had a visiting student, and the murderer was also not from this country. So this could have been a completely dead case.
Oh, yeah.
And obviously you played a big part in it. Now, it mentioned at the end of the what would you call it, the little TV special that the FBI was calling on you. Did you have any further cases, Bob?
Yeah, no further cases. I did go back and meet with the forensic team and the FBI in their technology division, and just chatted about what we did, and their big interest at that point in time was on the software side of it, of taking CT scans, 3D CT, and building the clay essentially in a virtual world. They were not to the point where they were doing an output, a physical output of it, and so they were. The whole idea of virtual forensics was just starting, not because, people knew from day one that this would be a really powerful set of tools, but the software and the tools to use it just weren't developed far enough until about that time frame, until 2000. And of course now they've got all sorts of different packages, forensic packages, and ties into rapid prototyping and everything else. But that was another example of until you try it in a real case, it's hard to tell just how useful new technology is.
No, and obviously it's spectacular results. So, Chris, I apologize for interrupting you earlier.
No
go ahead and
worries.
bring up some questions that you.
So LOM, which stands for Laminate Object Manufacturing, it's been around for a long time. We were talking earlier before the show. Some of the people that I know that have been in the additive game for a long time, that was what they were using, pretty much in the early stages of additive manufacturing. But but my understanding is that the big dog in the LOM market like went under.
Yep.
And so what was the machine you were using?
Well, they were still back in 1999. I think the company had disbanded, but there were still resellers, aftermarket people who were keeping an aging fleet of those machines running. And in my world back then, which was back in Milwaukee, most of the people who were using that type of technology were using it to create patterns for sand casting, for example. So they were making big objects, and this is back in '87 through 2000, when stereolithography, you just couldn't do it. It would be way too cost prohibitive. But if you cut something out of paper and stack it up, you made big things that had good dimensional stability. They were cheap. It was a great system.
Right. And what was do you remember what the brand of machine was that you were using?
Helicis.
Helicis. Okay. Yeah, because and so now today, basically, there's an Irish company that's come out, and they don't like it when, because I talk to their reps all the time, and they don't like that I call it LOM, but it's essentially the same thing, but instead of using a laser, it uses a blade. So they say, oh, it's a much different process. Oh, yeah, it's much different. It uses paper. It's the same thing. It's been around for a long time.
Yeah.
But, yeah, same thing. So the M-Core Iris is kind of very forward-thinking machine out of Ireland. I don't know if you've seen that.
I haven't, no.
But it allows full color, because what it does is you can print, it has an inkjet printer, and it barcodes each page.
Yeah.
And so you put in a ream of paper, just like you would with LOM, and it prints an ink that penetrates the paper enough on both sides. It duplexes each page, and then it feeds those sheets in, and then what you're left with is a full color model.
Now it's just the edge, though, right, Chris? It's not the full page that gets colored.
Yeah, only what's exposed. Here I can.
Okay. So while he's doing that, if he doesn't bring it up, I'll come back to you. Let's kind of move on. He brought it back up. So this is the M-Core, and we both saw it, and obviously Chris has been keeping track of this for some time now. It's got some very nice models. Do they have some demos on their models? They're very vibrant. The color is one of its big pluses. But as you said, the technology has been around, and let's see, they show some. There they go. So if you notice, they actually have a skull down there on the left-hand side.
For $13 printed, So,
yeah.
It's printed out of paper, so it's got stability of wood essentially, or it's similar.
Now, when I say $13, that's consumable cost, Chris. It's not
right.
Time
but compared to production FDM, you're talking for that same thing that wouldn't be full color on an FDM system. I would say it's probably a fifth or less the consumable cost. So
yeah,
I think it's a great technology, and I'm just always baffled when I hear these the early adopters that were in the additive field, and I'm baffled that this technology went out. But I guess it's just a business thing. It's like
it was that they were ahead of the market, and I think that if somebody was brave enough to go back in now with some of the old technologies or old concepts, but with new technologies, there are better CO2 lasers that are more robust. There are things that were wrong with that Helicis system that could be improved. But the fact of the matter is, it used reams of butcher paper. I mean, that's a great consumable. And if you want to build large parts that can be used as patterns and molds and things like that, it's still a great technology. So I think it takes the right entrepreneur, but I think that is definitely a technology that should be resurfaced.
Yeah, and as you mentioned, they do have newer LEDs, solid-state versions that provide enough power to cut through paper. So you are seeing newer techniques.
Yep.
In fact, I wouldn't be surprised that this might be something HP might be working on. but that's speculation. So let's move on to something else, and I'm going to pop to my screen. You know, we've heard in the news, oh gosh, for the last 3 or 4, we've been covering it, and then we popped the cork last week because there was an actual part was printed up on the International Space Station. But you know, just like this paper laminated technique that you used back in 1999 and before, we now find out that that's old hat because we were doing microgravity tests back in, what's the year on this?
What is the year? It's got to be 98, 97?
Well, I'd have to go to the bottom.
I don't even remember. It's so long ago.
But you were doing testing with FDM processes on the same thing that they were doing a lot of promotion, the KC-135, the
Yep.
vomit, what do they call it?
The vomit comet, that's right.
And so did you actually go up in this, or just were you on the ground?
Yeah, no, we did 80 drops over a 2-day period, and it was a combination of, we had 2 teams. There was a group from NASA, and they were the ones who took the, God bless them, the brute force engineering approach of taking an FDM 1600, there it is, and their first experiments were turning it on its side and seeing if you could build parts. Their next experiments were turning it upside down and seeing if you could build parts. I love that kind of engineering. They just, I mean, theoretically, back then everybody knew that you should be able to use FDM to build pretty much limitless geometry in zero gravity as long as you have a surface that you're depositing onto, because it's the surface tension of the liquid that's the driving force even in gravity. So gravity really doesn't matter. And so they did some ground studies. Yep. And I was working.
If anything, your test probably showed that, like FDM here, you normally have to build a support structure because of gravity. I'm assuming that you didn't have to use support structures.
No, you need some substrate to deposit onto, because in absence of gravity, if you're not sticking to something, it's going to tend to ball up. So it'll turn from a bead into a sphere, and so you'll lose some shape. But certainly, you can modify the FDM process very, very readily compared to SLA or SLS or any of the other processes that were active at that time. FDM and the Stratasys system back then seemed like the best candidate for a space station. And so there it is in that picture. It's mounted in the KC-135, and then my team is actually behind it. You can just barely see it in the picture there. I had a group of students, and we built a custom rapid prototyping system that was smaller. It used the same FDM technology, but it was designed to actually it was going to be launched on a space shuttle experiment. Back in the late 90s, they had what were called getaway specials, and these were little cans that fit in the cargo bay of the space shuttle and could do supplemental experiments. And that's what this experiment was designed to fit in. We had a slot reserved on one of those getaway special cans, and so we were doing our testing for our space shuttle experiment while NASA was doing their testing for for eventual use in the space station. And this is long, long, long before it actually got to where it is now. But we were both doing proof of concept studies to demonstrate that this is not only possible, but this is useful.
And it's funny because it was a big hoopla over the last what's it been, a year, that this was something new, and then what do we find out? Bob's been doing this for 20 years. And so it is interesting that how we want to promote this, but I'm wondering, they went up, and obviously it makes sense you'd have to test it using the Vomit Comet, their particular FDM printer that they sent up there. But I'm assuming that they got a hold of these papers and all the data that you had worked with in order to hopefully not restart the engine again and spend lots of money, which I'm assuming the government. What was the name of the company? Made in Space? Was that the name of the company that actually created the printer? But I'm assuming it was probably funded through federal funds.
Right.
So hopefully they used information that you had put together. So very cool. So again, your experience shows. And on that note, let's kind of move into, the only reason that I found about you is that I heard that you were giving a talk at, what was it, Science After Dark, and I had, actually I think it was our user group meeting or some other event that occurred at the same time, so sadly I wasn't able to make it, so I'm glad that we were able to have lunch and talk further on this. But you gave a presentation on how 3D is introducing itself into biomedicine, and we just last week did a interview with a couple of professors out at Rice University in Houston that are using a unique technique in order to create the capillary or the internal infrastructure in order to provide nutrients and remove waste by using sugar lattices in order to, and then removing the sugar, which leaves obviously the
Sure.
the capillary.
Yep.
So it was interesting. We talked to them, and so I'm just kind of wondering, are you moving into doing something here at Cal Poly like that? Is there some super secret work down in the basement?
We were doing that sort of work, gosh, about 8 or 9 or 10 years ago. I have stepped back from that work because I've got other stuff I'm doing. But we were our technique here that we were doing at Cal Poly in that area was almost like LOM, Back to the Future, or like that system that you described. Instead of printing on paper, we were printing cells onto dehydrated gelatin sheets. So if you make gelatin of a particular composition, you can dry it out into films that look like the old overhead transparencies. They feel like plastic films. And we're using that as a layered substrate, and then using just a simple syringe system to deposit cell grouping or selective cross-linking agents to toughen up the gelatin and deposit it in whatever pattern you want in that layer. Put down manually, put down another layer of gelatin, and keep doing that. And the goal for that was to demonstrate the technology behind making complex, I don't want to say tissue. Our goal was not to make tissue. Much of the work in 3D printing for bioplotters and other things like that, the goal is to make implantable tissue. Our angle at Cal Poly was to use tissue engineering techniques to make non-implantable, squishy machines. So for example, right now we do all sorts of things with engineered bacteria. They're great for wastewater cleanup and making pharmaceuticals and all sorts of things.
Mm-hmm.
If you genetically modify bacteria, you can use it as a little tiny factory. If you use an analogy to humans, that's just working with a cell. But tissues do things that are at a much higher level than just individual cells. So a tissue is made of cells, but it's greater than the sum of the parts. What we were trying to do is make a machine that had a number of living organisms, living bacteria, yeast colonies, other things, but that functioned together as greater than the sum of their parts. So essentially, if you can visualize the final product, and we never got there, but we were doing some of the early work.
Uh-oh.
Oh no, he just went black. Well, let's see if he'll come on. So it's...
Yep, there he is.
Oh, good, he's back. All right, we'll go back to him. Robert, are you there still?
Looks like he's connecting in.
Yep. All right, well, as he's going, I'll drop back to me.
I am back.
There we are.
Sorry about that.
Don't worry.
No, that's okay. That's what tech is all about, right?
So you were talking about cells.
Yeah, well, so if you can visualize the final product of that activity would be a block of gelatin, cube of gelatin with an extremely complex internal structure of cell colonies that functions. It's not meant to be implanted, but you put something in one end and you get something out the other end. So you put a food source on the inside and you get pharmaceuticals out the other side, or you put a nutrient source on the inside and you get different types of complex lipids and milk products out of the outside. And so that was the angle that we were doing. It was 3D printing was absolutely a critical part of it, and it was tissue engineering, but it wasn't human tissue, and it wasn't the goal of making an implant. It was the projection that in the future, if we want really sophisticated chemicals and things like hydrogen production or wastewater remediation, we have to have machines that are made more like the human body makes machines.
Unbelievable.
So
right?
essentially, they were organic black boxes. You put
Organic
something
black
in,
boxes.
and-
That's right. Yeah.
Yeah.
So that was the
pretty
work that we were doing. We started that, and then it became too hard, so I gave up.
Yeah.
Unbelievable.
So what are you working on now? And do you own your own 3D printer, or do you plan to get one? And you plan to come to our next user group meeting?
Well, so I have taken a leave of absence from the 3D printing community as a researcher. I haven't done anything since that tissue engineering work that I just described for about 7 or so years. I've been very involved in a number of startup companies that are biomedical products that over a whole different range of applications. So I'm a rapid prototyping user, 3D printer user for my prototypes, but all the exotic fun stuff I've stepped back from for a little while. I'll get back into it at some point. I don't own personally a 3D printer, but of course we have lots of them on campus here, and I run a program at Cal Poly that's called the Innovation Sandbox, and we have 3D printers there for the students to come in and use, and I'll come in and use them just as much as they will. So so I'm definitely still a user.
One of my clients is actually in the hothouse. So and he's working on some amazing stuff. There's just so much amazing technology, in the pipeline all the time, that's ready to revolutionize the world at any given moment. It just needs to be given a chance. So these little incubators like the hothouse, I think we're going to see a lot more of them be popping up. A place where it'll be almost like a replacement for banks, if you will, where we can see, or and it'll kind of be in between Kickstarter and a bank, where investors, venture capitalists can go and they can identify projects that are they see promise in, especially financial promise, and they can hopefully give some of these people some dough to launch their projects.
And we're seeing more than as you're probably aware of, Chris. I've been working with Autodesk for a few months now. We've got a couple of evangelists, but they started a new program called Spark that's doing the same thing, except Autodesk is funding it. So you submit your ideas or plans, and then they'll figure out what they can do to help you. Either it's financial or tools. So you're seeing a lot of larger companies now being involved in as they call it, the Spark initiative. And so not only are you seeing the group funding, but you're seeing actually companies getting involved. And I think that's smart on Autodesk's part, because it allows them to start at the beginning. And we've talked about several of their tools here. And as you mentioned, you used Autodesk way back when.
Way back when, when they had no intention of using it for rapid prototyping.
So, well, gosh, that time flies. But we really appreciate, Bob, for you coming on.
Sure.
It's funny how we met, but I'm hoping that we'll do a roundtable in the future. What's the name of the other gentleman that you have out there?
Martin Cook.
In 3D. I'm sorry?
Martin Cook.
Martin Cook.
He's like me. He's one of the dinosaurs of the industry. He's been around. In fact, I had no other connection to Cal Poly besides Martin. I used to call him up back in 1992, 1993, because he was doing the same sort of hacks that I was doing. So we've known each other since the early days.
And he's still working with FDM and other rapid prototyping devices, correct, out there at Cal Poly. So what I'm hoping is our roundtable for 1st January, or not 1st of January, in January, to get you as well as Art Cook on and just kind of talk about the old days, dare I say. Not for me, but for you guys, and just kind of see where that all goes, and maybe bring in some people from the outside to join us, so we can have about 5 or 6 people. I know that maybe John Ollie will join us from CNC, who has a real deep groundswell of people. They developed some Delta printers, and they just seem to have a lot of back knowledge, and I think it would be fun to have somebody like that on to just pick your brains, because obviously you're both well seasoned in it. So look for something probably third week of January, and hopefully that you can attend. And I'll try and get something out soon to have you both, and maybe bring you over, and we'll have dinner and actually set up a table here and do it in studio.
Sounds great.
But on that note, Chris, you want to take it? And
all right. Well, thanks
us
so
down?
much for joining us, Dr. Robert Crockett. Was a great guest. I sure learned a ton. I know he could probably talk to us for hours and hours and hours, and we'd still just be like. So, yeah. So thanks so much for coming on the program, and thanks to all our beautiful listeners out there. I hope you learned as much as I did, and we'll see you next time on All Things 3D.
Bye.